As promised, here is the first of the business subjects that I wanted to cover with you. I think this is a really, really exciting topic. If you like analytical things, where there's something that you can calculate, put together with that analysis in business where you have to make a decision from the answer, this is really exciting. So this is called critical path analysis or network analysis. Critical path analysis because what you do is you are going to calculate from a series of activities that are needed to complete a project, which of those activities are critical in that they will hold up the project if they are not completed on time. So you have a complex project, there are many small parts to it. Some of those jobs can be done at the same time, but others have to wait for something else to finish. You need to find out what's the fastest that you can complete the project. Will it be done by a certain deadline? You can also decide which jobs you can reduce staffing on or pay on while you wait for another job or while you put hours onto another job. This helps you get some figures, but then you need to do some clear thinking once you have the calculations. So it's a project analysis and planning method. So this is the culmination of all of your business course. You've looked at different departments, then you've looked at strategy, how a company chooses strategy, where they should place themselves, and now you've got to make that strategy go ahead. You've decided on a project, now you've got to check to make sure that you can produce it in the time scale that you hoped or the shortest time possible. At the beginning you wouldn't be asked to make network diagrams, but there are some projects that I'm going to send, I think, which will have diagrams that you can create. Okay, critical path analysis, CPA. It looks like this. You have nodes. A node is numbered. You see these circles and the number attached to it. They show the order of activities. You then add into that the earliest start time. Notice that's the top number on the right of the node. That's the first, if we're talking weeks, the first week that activity could begin, and you'll see how that's calculated shortly. And at the bottom you write in what is the latest time that activity will finish. The nodes are joined together by the activity, which is lettered, and attached to that activity is the length of time that activity will take. And it's good practice for you to draw arrows to show the direction that the activities are taking place if it's a complex diagram. So here's an example. You have decided to make a cake for your friends while you're texting all your friends. Activity A, you are also making the cake. Activities B, C, D and E. Here are there is the cooking time, and we haven't gone as far as the eating time. So this is the sort of thing that in business you may be given. You're given the activities with their letters. You're told if any activities must wait for another one. So activity C, weighing out ingredients, must wait until all the equipment and ingredients are out. And mixing, activity D, must wait until the weighing of the ingredients is finished. Occasionally things need to wait for both activities, for more than one activity to have finished, and you'll see that in the diagram in a moment. And then here we are given an estimate of the length of time it will take. Here is where, when we've finished making our diagram, there may be questions about whether these estimates were correct, whether people have the knowledge within their department to make that estimate, things like that. So here's a diagram that's been created from that table. So we can see we have activity A was talking to our friends while we then carry on making the cake, and then we have to cook it at the end. We've numbered our nodes, and we're going to write on the length of time. This is possibly how you might end up getting a critical path analysis diagram. So the next step is, ignore that for now, is that we need to work out the estimated start time for each of these activities. And the way that we do that is we take the previous estimated start time, we always start at 0, then we add the length of time, and that gives our estimated time, start time, for the second activity. And then 3 plus this 3 here will be 6, so that 6 should appear there. 6 plus 5 is 11. Now we have a problem, because here we have one more to add here. That could make this estimated start time 12, or we could say that we have to wait the 15. Well, clearly, if we're thinking about when we can start this activity, and we have to wait for A and E to have finished, then we have to wait the longest time. So this one here will be 15. And then this one's easier. We've got 15 plus 20, that will be 35. Okay, so EST here, it's 15, it's not the 12. Now let's calculate the latest finish time. So starting with the latest finish time, we work backwards through this chart. And we're again going to have a problem where anything meets on its return journey. So, starting with the same figure here, 35, the latest finish time here will be 35 take away 20, 15. Now we can work back through this channel. 15 take away 1, this will be 14. 14 take away 5. 14 take away 5 is 9. 9 minus 3 will be 6. Now we have a problem. The latest finish time here could be 5, 4, 3, or it could be 15 take away 15. And what we do is we, again, calculating the latest finish time, excuse me, is we take it back using, lost my tag, we take off the longest time. So rather than taking off the 3 and taking this down to 3 here, what we're going to do is we're going to take 15, take away 15, and we will end up with 0 here. Then what we're going to do is we're going to mark the critical path. And the critical path is where the estimated start time and the latest finish time are the same. There is no delay possible. So here we can see, I hope it will work backwards, oh it's going to work forwards. We can see here to here the same estimated start and finish, here to here same start and finish. But we can see here, we think we will start at 11 weeks in, but we don't have to we don't have to have completed this until 14 minutes. And the same here, we have to start at 6, but we don't have to finish until 9 weeks in order to keep all of this rest of this channel on track. Because we can see that 9 plus 5 would be 14, and 14 plus 1 would be 15, so we'd catch up. So it's important. I enjoy doing these because they're quite analytical, as I said at the start. They're quite like doing a Sudoku. They're quite a complex calculation. It's taken me, I thought I'd got it last week. I remember doing it at university, really enjoying it. I thought I'd understood it. And then I tried several different examples and I was just getting stuck, particularly on the latest finish time. So I hope that I've included a couple of examples that really help to explain that for you here, and are complicated enough that they include complexities that I was getting stumped on. Well, and it's very, very important here to remind you, this is what I meant to say, that the doing of the critical path analysis is interesting and it's a little mathematical challenge. But after that, the vital thing is that this is, just like with all the other scientific techniques you have, such as decision trees and all the calculations that you did with profit margins and looking at what you expect in the future, all of these are from estimates, and that is where your discussion in your company, when you are asked what should happen with a project, that's where your discussion should go. Are the estimates good? Are the people giving them knowledgeable enough? Can we expect other complexities that nobody's quite thought of yet? That's where your pay as a consultant will be valuable. Okay. So, as I say, we work from left to right for the estimated start time along the top, and the latest finish time works backwards. And I'm going to, where EST equals LFT, that's the critical path. And where they're not the same, there is slack, although this isn't perfectly true. My second statement is not perfectly true. There, I've put that right for you now. I'm going to stop this video, and then I'd like you to go through that exercise yourself, and then in the next video I'm going to show you an exercise that includes quite a lot of complex thinking, but I hope we'll talk through it clearly enough to help you.